Hello everyone, in this video we are going to discuss the solution for squares of a sorted array. So let's see how we can do this. Alright, then let's discuss our question first, then we will move on to its solution. Okay, so we have been given a integer array called nums. Let's say that this is my array, okay, which is sorted in non-decreasing order or just increasing order. Okay, and what we need to do is we need to create array of square for each number in sorted non-decreasing order. So simply what we need to do is square all these number present in this array. Okay, so for example, minus 25 square is 25. Minus 5 square is 25, minus 4 square is 16, minus 3 square is 9, 0 square is 0, 2 square is 4. We need to create an answer array in which all these squares are in sorted order. So it should look like this: 0, 4, 9, 16 and 25. Okay, and we should return this answer array. So this is what we need to do in this question. As I have done here, it is very simple. We can just create a answer array in which we store the square of all the elements and then we just sort it. Isn't it very easy? But if you will look at its time complexity, first what you need to do is square all the numbers and then add them to the answer, and then you need to sort this answer array. Okay, so squaring for each of the number and then adding to the this array will take some O of n time, and sorting will take probably n log n time, and overall complexity for this operation for converting into square array, then sorting that array will take time complexity of O of big O of n log n. But if you have read the constraint for this program very carefully, you will notice that we need to solve this problem in O of n time, not n log n time. So we can't do sorting. If we will do sorting, then it will take much more than our given constraint, and we can't change the constraints here. Okay, so let's remove all this. Okay, now this was my answer array which was sorted. Okay, let's assume something, that this is my answer array and it is filled. I know it is not filled, it's empty, but let's suppose it is filled in the way that we needed, in sorted non-decreasing order with square of each number. Okay, okay, so if I will pick this block, this element, okay, if I will say that I am choosing this element, will it be the largest element for this? This will be the largest element for this answer array. Yes, it will be the largest element because that is sorted in non-decreasing order or simply increasing order. Okay, now this is my largest, and if I will ask you, if this is the largest element for this answer array, then how can this answer this largest element is made? It must be made from either this element or this element, most negative number or most positive number. Now think about it carefully, what I have just said. This largest number that I have in answer array will be created by either the most positive number or most negative number. Just think. Okay, so Maybe you haven't able to visualize it, so let's take a guess. Let's take examples. So in here we have -5 and -2. Okay, this is my most positive, sorry, most negative, and this is my most positive. Okay, if I will square them, I will get 25 and 4. Obviously 25 is bigger and 25 will come here. Now this was my most negative or most positive. If I will say no, I was wrong and this could be the largest, this number square will be 16, this is 9, and this is 0. So obviously what I have just said, that either the most positive number or the most positive number or most negative number is going to create the largest number in the answer array. Okay, so let's take one more example. Let's say -9 and 25. Okay, these are the most negative number and most positive number. If we will square them, we got 81 and we got 625. Okay, so which is bigger? 625 is bigger, so largest element will be 625. Oh, that's some pattern here, right? If I'm able to fill this box by comparing these two numbers, then I am very sure that I will be able to fill all these number by comparing these comparison. First I will do with these two, then I will do with these two, then I will do with these two, like that. Okay, so let's take an example to apply this approach. So let's name this I and J, and let's keep a pointer for our answer array as well called K. Okay, so I will try to compare square of -5 and 2. Okay, so let's name them V1 and V2. V1 will represent square of the ith element and V2 will represent square of jth element. Let's name it square of I and square of jth. This is what V1 and V2 are representing. Okay, so let's start our comparison. I -5 square will be 25 and 2 square will be 4. Which one is bigger? 25 is bigger, so 25 will be placed here. Okay, now 25 has been chosen already, so I will shift to right. Okay, now -4 square and 2 square will be competing against each other. -16 and 4. 16 is bigger, 16 will be placed here. Oh, we forgot to move our K. K was here. Okay, now -4 has won, so I will move again. Now if I have moved I or even J, K is always moving when it is filled. Okay, just remember to do that. Okay, now -3 square, which is 9, 2 square, which is 4. 9 will be chosen and 9 will be filled here with at the area that is indicated by my K pointer. K will move, I will move also. Now 0 square will be 0 and 2 square is 4. 4 will be chosen and 4 will be filled in the answer. Now J will move from 2 to 0. Okay, it will move toward left. I is moved to our right and J is moved to our left. Okay, Now this will be my final comparison. 0 and 0. Who will win? 0 will win. So 0 will be placed here. I forgot to move this keywords here, and our comparison is done. And now for next loop, J will move here, and if we will try to do this comparison now, it is not possible because we have already made comparison for I and J. And now if you will try to look at here how many comparison we actually did, you can see this is my first comparison, second comparison, third comparison, fourth comparison, and fifth comparison. After my fifth comparison, my answer array was completely filled. And if you look carefully, you will find size of this array is nothing but 5. So I can clearly see that this loop has run for big O of n. Okay, now after this my answer array will be filled. Okay, now this is how we are going to do this. But let's suppose that you have all the positive integers. Okay, let's say you have 0, 1, 2, 3, 4. In this case, you don't actually need to compare like this. You can just do, what you can do is simply run your loop for this left to right and fill your answer array with the square of each element, because that is already sorted. It won't be very difficult to do that. Okay, but this will work only when you have only positive integer. In the constraint, you have to look very carefully. Okay, so we are done with the approach. Now let's try to implement it. Alright, then let's code this now. Okay, so first thing we need is a array, but instead of array I'm going to use vector. Actually vector is a dynamic array, so it is kind of a vector, kind of an array. So int answer. Now I need to give it some size. Now why I have to give it some size? Isn't vector dynamic? We can add anything to it. Look carefully what I'm doing. I was trying to fill my array from right to left. Okay, and initially vector is empty. If I will try to add it now, it will be added like this. Okay, instead of this I will get this, and I don't want this array because I have been given the question. I need to do this. I need a array of squares for each number sorted in non-decreasing order, and this is the decreasing order. Okay, I don't want that, so I have to give it some size so that it can be filled from right to left, not left to right. Okay, so let's give it some size. Let's give it n equal to nums dot size, because obviously the number of square element will be equal to number of element. So nums dot size, and that's it. Now I have given it n, and now I need pointers. I equal to 0, j equals to n minus 1, k equals to n minus 1. Now you may see that both j and k are equal to n minus 1, because the size of my answer array as well as my nums array are the same. That's why I have written n minus 1 for both of them. But you need to remember one thing very carefully here, that I and j are the pointers that are working on my nums array. Okay, and my k pointer is the one pointer that is working on answer array. Okay, So just keep it that in mind. Now simple while loop I less than equal to j. Now what I need to do is calculate value 1 and value 2, and v1 equals to, v1 was representing the size, not size, the square of ith element. So nums I star nums I, this is going to give me square of ith element, and same thing I'm going to do with my j element. Okay, v2 is going to store the square of jth element, and that's it. v2 equal to nums j square, and that's it. Now we need to just compare v1 and v2, whichever is greater, it is going to fill my answer of k. Answer is kth element. Okay, if v1 is greater than v2, then answer k equal to v1, and I will move to the right side, and for that I need to do I plus plus. Else it means that v2 is greater and v2 should be added to answer k. Okay, v2, and now we need to move our j from right to left, so j minus minus, that's it. Now we need to return, oh we forgot one thing, k minus minus, because k was also moving from right to left. Here you can see k was moving from right to left. All right, now what we need to do is return answer, and that's it. Now let's run it. So it is accepted for a sample test case. Let's submit it. So we got full marks, which means our code is completely right and it is following all the constraint that we have put on it. And the biggest constraint that we have put on it was that our program should run in O of n time, not in log of n, or not in n log n, or in n square. Okay, in our original approach, what we did was squared all the elements, then sorted them, which took time complexity of n log n, mainly because of the sorting. And here we didn't need sorting, all the elements were sorted by themselves. And if you look here, you will find that all the elements are all the comparison are made only n times, which was nothing but size. Okay, so that's about the solution of this problem, and I will see you in the next video with a new question. Okay, so till then, goodbye.